Our lesson today, vector product. Determinant of order 2 is of the form where A, B, C, D are real numbers. To calculate the determinant of order 2, we use the following way. We multiply A by D, B by C. Multiply A by D, B by C. So, equal A times D times D minus B times C. B multiplied by C. Let's take some examples. To calculate the determinant, we multiply 1 by 4, 3 by 2. So, multiply 1 by 4, 3 by 2. 1 times 4, 1 multiplied by 4, minus 3 times 2, 3 multiplied by 2. So equal 1 times 4 equal 4, minus 3 times 2, 6. So equal 4 minus 6 equal minus 2. To calculate the determinant of order 2, we multiply x by 3, y by minus 2. So, x by 3, y by minus 2. X times 3, 3x. So, call 3x. Minus y times minus 2. Y multiplied by minus 2. So, y multiplied by minus 2 equal 3x minus times minus plus, so plus 2y. Determinant of order 3 is of the form contains 3 rows and 3 columns and 9 real numbers. To calculate the determinant of order 3, we cross the first row and the first column. The intersection is A. So, we put it here. We put the intersection between first row and first column. So A. What remains is determinant of order 2. So determinant of order 2, E, F, H, I. Minus, don't forget minus. We cross first row and second column. And second column, the intersection is B. So we put it here. What remains is determinant of order 2, D, G, F, I. So D, F, I. Determinant of order 2 plus, so minus plus we cross the first row and third column. The intersection between first row and third column is C. So we put it here, C. What remains is determinant of order 2, D, E, G, H. So equal A. This is the determinant of order 2. So we multiply E by I, F by H. So multiply E by I, F by H. So equal E times I minus F times H. So F minus B. So this is determinant of order 2. Determinant of order 2. So multiply D by I, D times I, minus F times G. Plus C. This is determinant of order 2. So multiply D by H, minus E by G. So times G. Let's take some examples to calculate the determinant of order 3, because 3 rows and 3 columns. Determinant of order 3. We cross the first row and first column. The intersection is 1. So we put 1. What remains is determinant of order 2, 5, 6, 8, 9. So what remains? Determinant of order 2, 5, 6, 8, 9. Minus, we cross the first row and second columns. The intersection is 2. What remains? Determinant of order 2, 4, 7, 6, 9. So 4, 7, 6, 9. Plus, we cross the first row and third column. The intersection is 3. What remains is the determinant of order 2, 4, 5, 7, 8. So 4, 5, 7, 8. Equal 1 parenthesis 5 multiplied by 9, 6 multiplied by 8, because determinant of order 2. So 5 multiplied by 9, 5 times 9, minus 6 times 8, minus 2, determinant of order 2. So 4 multiplied by 9, 6 multiplied by 7. Plus 3, 4 multiplied by 8, 5 multiplied by 7 minus 5 multiplied by 7 equal. To calculate the determinant of order 3, we cross the first row and first column, the intersection x, so x. What remains? A determinant of order 2, 0, 1, 1, minus 1, 1. Minus y what remains? Minus 1, 1, 1, 1. Plus the intersection is 2, so 2. What remains? The determinant of order 2, minus 1, 0, 1, minus 1. So, equal x, 0 times 1, 0 multiplied by 1, 1 multiplied by minus 1. So, x, 0 times 1, 0, minus 1 times minus 1, 1 times minus 1, minus 1, minus y, minus 1 times 1 equal minus 1, minus 1 times 1 equal 1, plus 2 minus 1 multiplied by minus 1 equal plus 1, so plus 1, minus 0 times 1, 0 multiplied by 1 equals 0. Vector product, cross product of two vectors. The vector product, cross product of the vectors u and v, denoted by u cross v, or u cross v is vector such that vector w is orthogonal to both vector u and vector v. So vector w orthogonal to vector u and vector v. Vector u, v, and w in this order form a direct basis. Modulus vector w equal modulus vector u cross vector v equal modulus vector u multiplied by modulus vector v multiplied by absolute value sine vector u v. So angle between vector u and vector v. Let u vector u and vector v, then u cross v equal vector I g k vector u x y z, so x y z, vector v x prime y prime z prime x prime y prime z prime, so equal y multiplied by z prime, z multiplied by y prime, so y multiplied by z prime minus z multiplied by y prime, z multiplied by y prime, vector I minus minus plus plus. So example, let vector u and vector v calculate u cross v. So u cross v equal vector I, vector g, vector k, 1 minus 2, 1, so vector u, 1 minus 2, 1, 1 minus 2, 1, vector v, 3, 0, 4, 3 0 4. So equal minus 2 multiplied by 4, 1 multiplied by 0, minus 2 multiplied by 4, minus 2 multiplied by 4, minus 1 multiplied by 0 equals 0, so 0. Vector I minus 1 multiplied by 4, 1 multiplied by 3, so 1 multiplied by 4 minus 1 multiplied by 3. Vector G plus 1 multiplied by 0 minus 2 multiplied by 3. So equal minus 2 multiplied by 4 minus 8 minus 8 minus 0 minus 8 minus 8 vector I, so minus 8 vector I, minus 4 times 1 4 4 minus 3 1, so minus 1 vector G, minus 1 vector G, or minus G vector, plus 1 times 0 0 minus 2 times 3 minus 6 minus 6 times minus plus 6, so plus 6 vector K, plus 6 vector K. Calculate V cross U. So V cross U equal vector V 3 0 4, so vector U 1 minus 2 1 equal, so minus 2 times 4 minus 8 minus 8 times minus plus 8, so plus 8 vector I, plus 1 vector G, minus 6 vector K, so minus 8 plus 8 minus 1 plus 1 plus 6 minus 6, so vector U cross vector V equal minus vector V cross vector U.